I'm going to talk about classifying text using naive Bayes. Why? Well, we can learn, for example, which news articles are of interest, or we can learn which reviews are good, which reviews are bad. We can mine text for certain concepts. We can classify web pages by topic. There's a lot of applications when we talk about text classification, and naive Bayes is among the most effective algorithms to do this. There are many more algorithms that are more effective than naive Bayes, but naive Bayes is a very good baseline, and it's pretty effective. Um, so some of the things that we might ask, well, is what are the attributes that we will use to represent the documents? And we'll shortly see how that works. First, a little bit of an intuition of what we're going to do, what the process is going to be. Well, first, say we have a target concept, whether a document is interesting for us or not, right? So the target can be either positive or negative, right? So the document, I'm sorry, can be positive, classified as positive or negative. You can have many more other classifications, so positive, negative, neutral, I don't know, acceptable, unacceptable, uh, whatever the classes are. I'm just illustrating this with two classes. Documents can be positive or negative. So the first step is we're going to represent each document as a vector of words. What we're going to do is we're going to lay out all the words in the document, right? All the words in all the documents that we have, all the unique words, and that's going to form a long array of words. That's what's called a vector, and each document is going to use this long array of words. We'll see how. Then we're going to learn. You see, we're going to have training examples. So somebody has to grab a lot of, say we're doing movie reviews. Somebody has to grab a lot of movie reviews and classify them and tag them as positive or negative. Or someone has to grab a lot of text that is kind of like the same text that we want to classify later on, and they have to tag it as one class or another. The second step is learning. Like I said, we're going to use training examples, these training examples that I just talked about, to determine the probability of the positive outcome, the probability of the negative outcome, in general, the probability of any of the outcomes that you might have. It might be more than two. And then the probability of each document with each word in each document with positive or negative. We're going to be able to determine the probability of a document. Now, we're going to be based on the conditional independence. So basically what we're going to say is, this is very important for the math behind it, okay? But we're going to think that words are independent. So the fact that university and degree appear together, I will think, although those two words are dependent on each other, right? So usually when you see university, you'll see degree. But for our purposes, for simplification, we're going to say that university and degree can appear independently at any given point, just like a table and garden. I mean, they're totally independent words, okay? And with that assumption, the probability of a document belonging to a certain class, so for example, the probability that a review, that's what I call a document, that a review is a positive, okay? It's going to be going through the length of the document, multiplying the probability that each word classifies as positive. And then we're going to multiply one more probability to that, and that's it. Okay? The other thing is that because we're computing these probabilities of words when the outcome is positive, in documents which is positive, we're not going to care about the order of the words. So let's do a little example, and that this intuition is going to be a lot clearer. Say, for example, you have a set of movie reviews, which I call documents, and its corresponding classification. So somebody actually read these movie reviews and put a class next to them. So the first document says, I loved the movie, and it's classified as a positive review. The second document says, I hated the movie, and it's classified as a negative review. The third document says, a great movie, good movie. The classification is positive. Fourth document says, poor acting. That classification is negative, and the fifth document says great acting, a good movie, and that classification is positive. Now, movie reviews can be a lot longer than this, but just for the illustration purposes, these are, all the movie reviews that I have for training. You'd usually have in the order of thousands, if not many, many hundreds. So there are 10 unique words. I loved the movie, then hated, because I already have I, hated, and then I already have the movie. Then A, great, I already have movie. Good, poor, acting, great, and that's it. Okay, so these are the unique words. There are 10 unique words. Yes. It is important. So what we're going to do is we're going to convert the documents to feature vectors, okay, where the attributes are all possible words and the values are the number of times a word occurs in the given document. So, for example, for document 1, I'm going to lay out all the unique words along here. And document 1 is going to be 1, 1, 1, 1, and then the rest are going to be zeros. What that means is it has the first word, which is I. Document 1 contains the second word, which is loved. Document 1 contains the third word, which is contains the word movie. It does not contain any of the other words. And it was classified as positive. The second document, right, same thing, contains the word I, the word the word movie, and the word hated, and everything else is zero, and then the classification is negative. Then the third document contains the word movie twice. So I put a little 2 here. The movie A, the movie great, the word A, the word great, and the word good, right, once. So everything else is zero, and that was classified as positive, and so on and so forth. So I represent each document, each review, as an array or a vector of numbers, where there is zero if the corresponding word is not present, and it's the number of times the word is present otherwise. Okay, so let's look at the probabilities per outcome. So we have to choose whether we look for positive or negative first. We're going to look for both, but let's do positive first. So documents with positive outcomes. I see document 1, 3, and 5 have positive outcomes, and here are the vectors, the word vectors. So first, let's compute the probability that a document is positive. The probability the document is positive is 3 out of 5 documents, that's 0.6. Then we have to compute the individual probabilities of the word I given positive, love given positive, the given positive, and so on and so forth. Actually, all the words. I just put the words that have a positive outcome associated to them, but in reality I do have to have the computation for all possible words in the vocabulary with the positive outcome. Okay? Now, intuitively, to compute the probability of I given positive, I have to compute the times that I is used as a positive example divided by all positive examples there are, all words that yield positive examples. So with that in mind, we're going to say that n is the number of words in the positive case, that is 14. N sub k is the number of times word k occurs in positive cases. So for example, here the word movie occurs twice in the positive cases, so nk would be 2. All right, and then the probability of a word given the positive outcome, okay, is nk, so the number of times word k occurs in positive cases, plus 1, divided by n, which is the total number of words for the positive case, plus the size of the vocabulary. All right. We do this so that if a word does not occur in the positive case, then this thing is 0, but the whole probability is not 0 because there's a 1 here. Okay? All right. So let's look at the positive outcomes. So the probability of positive is 0.6, we just saw that, and then I compute the probability of each word in the vocabulary. So the probability of I with positive is 1, because there's one case where the word I is present in a positive case, plus 1, because the formula says to add 1, divided by the total number of words for the positive case plus the number of unique words in the vocabulary. And that gives me, in this case, 0.0833. I compute the probability for each word here. So for example, let's look at the probability of movie, right? The probability of movie, all right, with plus. Movie appears 5 times. Oops, I got this wrong. It's 4 times. Movie appears 4 times in the positive case. This should have been number 4 plus 1 divided by 14 plus 10. Okay. What else? The probability of the word A, for example. Probability of A with positive outcomes. A appears twice here. So there's number 2 right here. Right here there's number 2. Plus 1, like the formula says, divided by 14 plus 10, which is n, 14, the total number of words in the positive case, and 10, which is the vocabulary. And so on and so forth. So I compute all the probabilities of with all the words with the positive outcome. Like we just saw, I apologize, we have one wrong here. We might have others slightly wrong, but it's not so important as long as you compute them correctly. Now let's look at the negative examples. Documents 2 and 4, right? Here's documents 2 and 4. And those are the vectors. So the probability of negative in this case is 2 over 5 because there's 2 negative examples out of 5 examples total. That's 0.4. And the probability of all the words with negative examples, right? Now, all the words appear once in the negative example, so they're all going to have the same probability almost, okay? Now, one thing I didn't mention earlier, but it's that I also included words that never happen in a negative case. So for example, loved never happens, you see? There's no document containing the word love here. So love never happened. That's 0 for n sub k. N sub k is the number of words with the outcome that you want. The number of times the word that you're looking for, in this case loved, appears with the outcome that you want. That's 0 plus 1 divided by the total number of words for this outcome plus the size of the vocabulary, or the number of unique words. So I compute these probabilities for all the words now given the negative case. Then we have trained our classifier. We know all the probabilities for all possible words in this vocabulary. And we can classify a new sentence according to the following. The classification of that sentence, the value of the naive Bayes classifier, it's going to be the value that gives me the highest number when I compute this probability. Argmax means the value that gives me the highest number. So what I'm going to do is the probability of, say, if I'm going to test first the positive case, then the negative case. I'm going to test the probability of positive times the probability of each of the words that I have in my new sentence given the positive case. I'm going to do the same for negative, and the one that gets the highest number, that's the probability that wins. So I do it here. So say the new sentence is this one, is I hated the poor acting. Okay? So if the value is positive, I'm going to multiply the probability of positive times the probability of I with positive, because that's the first word, then the probability of hated with positive, then the probability of the with positive, the probability of poor with positive, the probability of acting given positive. I get a value of 6.03 times 10 to the negative 7. I will do the same with the negative case. Okay? Now I do it for the negative case. And I have the probability of negative times the probability of I with negative, the same words, hated given negative, the given negative, poor given negative, acting given negative, and I get 1.22 times 10 to the negative 5, which is clearly the higher value. So I can say that then the comment or the review is a negative review. Okay? And that is basically how you classify text. Now, here's a little algorithm, like pseudocode, for training the Bayesian network for training the probabilities. You can stop and look at it. It's taken from Tom Mitchell's machine learning book, and this is how you would train. You stop this slide if you want to code this on your own, and here's how you classify a new word, right? So classifying a new word is basically compute this argmax. Now there are many things that could happen here. For example, what if instead of, say, for example, I hated the poor acting, I would use I did not like this poor acting. The words did, not, and like are not in our vocabulary. So we have to be able to handle those words. And usually what you do is, if you haven't seen a word in your vocabulary, you find a reasonable way to assign a very, very tiny number to that word, to that probability. Okay, that is beyond the scope of this video, but keep in mind, if you have unknown words or unseen words, just assign them a very, very, very tiny probability, because we don't want to rule them out. We don't want to rule out that they'd never happen with a positive or negative outcome. We just have to admit that perhaps our data is not so complete, or perhaps somebody just made up a new word and it has some meaning. Okay? So with that and these two things here, I conclude this video. I hope you liked it.